Hi algebra students, we are going to jump into the 9-2 substitution method notes. The first thing I want you to do, however, is to back up a little bit and practice the graphing method. You're going to graph the system 4x, and this should be a plus, so just fix that on your paper. Y equals -3 and 5x minus y equals -6. You know that you need to have them in y equals mx plus b form before you graph. So you want to use the space provided to put them into y equals mx plus b. So the first equation has a y-intercept at -3. So you're going to go down on the y-axis, down 3, make a dot. And then you're going to use the slope -4/1 to plot the next dot. So I can either go down 4, 1, 2, 3, 4, and to the right 1, or it's also the same to go up 4, 1, 2, 3, 4, and to the left 1. And I'm going to go ahead and keep making dots. I can go up further on the left side, so I'm going to go up 4 more, 1, 2, 3, 4, and to the left 1. And once I have a good number of dots, I'm going to connect those to form my line. Now I'm going to graph my second line. It has a y-intercept of 6 and a slope of 5/1. But you notice if you go up 5, you're going to be off your graph. So let's think about 5/1 as being -5/-1. So I'm going to go down 5 and to the left 1, and up, I'm hitting the second line, or the first line. So when I draw my line for those two red points, I'm going to see that the intersection point between this system of equations seems to be at -1, 1. But in order to check, what I want to do is I want to plug it back into both equations. Starting with this one, I'm going to go back to the original form. So 4 times -1 plus 1 has got to give me -3. And it does. So it works for the first one, but in order to be a solution for the whole system, it's got to work for both. So 5 times -1 minus 1 has got to equal -6, and it does. So we know that the ordered pair -1, 1 is our solution to the system. If you think about it, though, solutions don't have to be pretty numbers, and they don't have to be pretty coordinate plane pairs or ordered pairs. So sometimes when you graph, the intersection does not occur at an integer. And what I mean by that, it doesn't occur at something pretty like -1, 1. Maybe we'd look at an ordered pair like 2, -3/4. That would be difficult to see on a graph. So today we're going to talk about the substitution method, which doesn't involve a graph, which allows you to get those less than desirable ordered plane, coordinate plane ordered pairs. So taking a look at example 1, I want to look at the two equations I'm given, and the top one in particular is going to be really helpful for the substitution method because it's solved for y. So following the steps that we have here for you, the first one is we want to substitute the expression that y equals into a second equation for y. So essentially what we're going to do is we're starting with two equations with two different variables. And through the substitution process, we're going to substitute one variable for the other, eliminating the fact that there are two variables in one equation so that we can solve it. So we'll take a look at y equals the opposite of x minus 15. That tells me what y equals, so I'm going to go to my second equation and I'm going to replace y with what it equals. It says y equals this. So I'm going to replace that y with the opposite of x minus 15. So because it's called the substitution method, that's what you're doing. You're substituting in what y equals to one of the equations. And now you'll notice all my y's disappeared and I just have x's. So all I have to do is solve this algebraically. I'm going to look at this as plus -3 that I'm distributing. I'm going to get 4x plus positive 3x plus negative, or pardon me, positive 45. And then I'm going to combine my like terms and solve for x. So through that substitution process, I found x equals negative 1. But if you think back to the first example, we need an x value and a y value to make up our ordered pair solution. So the third step now is to substitute the value of x back into the first equation, the one that you plugged in. So we had the equation y equals the opposite of x minus 15, and I'm going to replace x with negative 1. So this is going to be y equals the opposite of negative 1 minus 15, which gives me 1 minus 15, which means y should be negative 14. So that means that my solution should be negative 1, negative 14. And I'm going to show you a way to check that in a second. But if you think about this, it's kind of nice that we didn't have to find this ordered pair on a graph, because most of our graphs do not go up to, or down to rather, negative 14 on the y-axis. So now what we're going to do is we're going to replace x with negative 1 and y with negative 14 into both of the equations and make sure it checks out. So completing my check here, I've got negative 14 equals negative 14 for the first one, 38 equals 38 for the second. It works for both, so it must be the solution of the set. So here's the your turn, and before you start it, you need to change the second equation to a plus sign. That should be x plus 4y equals negative 9. What you want to do is you want to solve the bottom equation for x, because it doesn't have a coefficient, so it's easiest. So that's going to look like this. I've got x plus 4y equals negative 9. I'm going to move the 4y by subtracting it, and that gives me x equals, doing a little commutative work here, negative 4y plus negative 9. Now this might feel a little foreign because I moved the y term instead of the x term, which we haven't done up until now. What you need to know is it doesn't really matter which one you solve for. I could have solved for y, but it would add an extra step of dividing by the coefficient. So it's best to go with a variable that is either already alone or doesn't have a coefficient. What I'm going to do is I'm going to replace x with negative 4y plus negative 9 in the equation I haven't used so far, the top one. So my plug-in line is going to look like this. I replace the x with negative 4y plus negative 9. It's really important to put it in parentheses because both of those need to have the 2 distributed to them. That gives me a negative 8y plus a negative 18 minus 3y equals 4. I can combine my negative 8y and negative 3y to be negative 11y plus negative 18 equals 4, and solve for y. So I'm finding y to be negative 2 through that algebraic work, and now I've got half of my solution. All I need to do is find the second half. So I'm going to go back to the original equation that we used, x plus 4y equals negative 9, and this time I'm going to replace y with negative 2 and solve for x. So I'm finding x to be negative 1, which means if we did this properly, our ordered pair should be negative 1 comma negative 2. But again, I want to be really cautious and I want to check. So I'm going to plug that back into both of the original equations in my system. So both my plugins worked and they both checked out, so I know my solution is negative 1, negative 2 for my system. For example 2, we're going to take a look at this system, 2x minus 8y equals 6 and x minus 4y equals negative 9. If you remember what we talked about for a prior example, if you've got a variable without a coefficient, it's probably easiest to solve for that one. So we're going to solve the bottom one and get x alone. So we started with x minus 4y equals negative 9. And I'm going to move the 4y over by adding it to both sides. That means x should equal 4y plus negative 9. Now I'm going to take that 4y plus negative 9 and replace it for x in the top equation. So 2x minus 8y equals 6 was my original equation. Now I'm going to replace it for both of those pieces, and I'm going to solve for x, or y, pardon me. This gives me 8y plus negative 18 minus 8y equals 6. And something should be looking a little fishy to you because we've got 8y and negative 8y and they cancel out. So if we look at this, that's certainly not a true statement. And what this means is when one of the variables cancels out and you can't find a value for y, that means that there is no intersection point. And if you think about two lines that don't intersect, that means they should be parallel. But I want to go ahead and prove that. So what I want to do is I want to go back to the equations and I want to figure out what their slope is by solving them for y. So I got those two equations of my system in y equals mx plus b, and I'm seeing that the slope of the first one after I reduce is 1/4 and the slope of the second one is 1/4, and the y-intercepts are different, which means that I was right. These lines are parallel. So on our quiz test, if we ask you to solve the system by substitution and one of the variables drops out, it completely disappears, that means that there is no intersection point and that they are parallel. Make sure you bring any questions to your teacher on the next instructional day.